Okay, just to start talking about limits, because as I said, in this course, we don't necessarily assume it's been done completely. You know, first year calculus course, or that people even really understood it that well in the first year calculus course, although some people do, maybe everybody here did. I say it's time that a typical class all grows up and does limits in some kind of a thorough fashion, okay? And we base it on what you learn in calculus, but we want to review that a little bit. And of course, you know, everybody is grown up, but just talk about mathematically, okay? At least most of the class is fairly grown up. I don't know if I am, you know. Okay, here we go. So, we said limit as x goes 0 from above of 1 over x, meaning x approaches 0 through positive numbers. And you can actually sketch a little picture here. We don't need 2 dimensions. I learned multivariable calculus. I'm just used to drawing a 2-dimensional or 3-dimensional set of coordinate axes. It's like being able to draw a 4-dimensional, but you know, we can't visualize 4 dimensions. We can work in 4 dimensions, which is fine. Okay, but anyhow, here's 0. So imagine x approaching 0. Okay? So here's x approaching 0. And the closer x gets to 0 from above, so x is kind of approaching 0 like this. The closer we get to 0, the smaller the number we're dividing into 1, which means the more of these it takes to make 1. So let's just say the 1 is out here somewhere. So already it takes a lot of these to make 1. You know, maybe 10 or 15 of them, say 10 of them. By the time we get here, it takes over 100. And the closer we get, the more of that x it takes to build up 1. Okay? So it's clear that there's no limit to how close we can get to 0. So there's no upper limit on how big 1 over x can get. So we're going to say that 1 over x approaches infinity. Okay? And the limit is infinite. And again, above. Now if we approach 0 from below, the same is true, except the quotient's going to be negative. So it's going to approach negative infinity. To make that a little more rigorous, just let n be any positive number. If x is less than 1 over n, then 1 over x is bigger than n, right? So if x, a positive number x, is small enough, 1 over x will exceed any positive number. Okay? By small enough, if we want to exceed big N, we just let x be less than 1 over. Simple. It can be as much less as we want. Or it can be as close as we want to 1 over n. Doesn't matter. The reciprocal is going to be bigger than n. So, we'd say, then, without writing it out with total rigor, but this is semi-rigorous, okay? There are a few little details we've got to fill in. But we're going to be able to say that as x approaches 0 from above, 1 over x approaches infinity. And we write the limit as x approaches 0 from above, 1 over x is infinity. Now if we have a function 2 variables, then it lives in the plane, and you're going to be approaching some value, well, some point in the plane. Okay? In 3 variables, it's going to be approaching some point in space. Well, one of the simplest examples we can do, probably the simplest, is to say the limit is to find the, to find the limit as your point, xy, approaches 0, 0. Okay? Of 1 over x squared plus y squared. This means that xy could approach 0. Well, there are a lot of ways it could approach 0, right? It could approach 0 along a dotted line here. Okay? So, okay? Approach 0 through any line. There's another line. It could spiral in. Okay? It could approach 0 through a set of random points that are closer and closer to the origin. So, you parameterize any curve you want, have x, y approach 0 along that parameter's curve, as long as the curve approaches 0 as a limit. X, y could approach 0 along a bunch of random points, each closer to 0 than the preceding. I'd have to number these to see, but I think this one is the furthest away. I don't know which one of these is closer. I'd say further. I'd say this one is, then this one, then this one, this one, this one, and this one, okay? So, and x, y doesn't approach 0, it points, approaches the origin, right? Okay? A lot of ways x, y could approach 0, 0. And sometimes you have to consider how x, y approaches 0, 0. If you have, for example, a hyperboloid with a saddle point at 0, 0, we'll see that later. If you approach along some paths, you approach plus infinity. If you approach along other paths, you approach negative infinity. Actually, this would approach plus infinity either way. If it was 1 over x plus y, then it could be approaching positive infinity or negative infinity, depending on what path you took. Wouldn't even have to necessarily be a hyperboloid. Okay. And we'll see that. But it's something you want to be prepared for. It's not as obvious in 2 dimensions as it is in 1 dimension. Mainly because of what I just kind of alluded to, okay? If it was 1 over x plus y, then if you approach 0 along this path, x plus y is always positive, and you're going to get a positive infinity limit. If you approach along this path, x and y are both negative. So you're approaching infinity through negative numbers. You're approaching negative. You're approaching 0 through negative numbers. Reciprocal would be negative infinity. Okay? Well, reciprocal would approach negative infinity. So if you approach along this path, well, the magnitude of x is bigger than the magnitude of y. So x plus y along this line is always positive. But if you go up to this line in this quadrant, y is always bigger than x. Okay? And I'm sorry. Along this line, the magnitude of x is bigger than the magnitude of y, but x is negative while y is positive. Okay? And what I said is true. Then x plus y along this line would always be negative, but along a line closer to the y-axis, y would be bigger than x, and y is positive while x is negative in this quadrant. Okay? So you have all that. Now, I'm just tossing that out right now, but hopefully you understand that and want to maybe think about it a little bit, because some of the problems might involve that sort of a conundrum. Okay, the magnitude of the reciprocal of x plus y does approach infinity. But x plus y itself could approach positive infinity or negative infinity depending on what path you take. And if you approach through random numbers, random coordinates, sometimes you're going to get positive, sometimes you're going to get negative. Okay? And the number's going to be really big. It's either going to be out that way toward infinity or back that way toward infinity, and you're not going to get a limit. Okay, well, in any case, for this function, if xy is inside the circle, then the square root of x squared plus y squared is less than delta, right? So x squared plus y squared is less than delta squared. Probably not a good choice to have used delta, but I used it anyway. Okay. It still works, just not in the way you would, not with the notation that you use in a formal proof. So the point is then, of course, delta squared is less than delta. Okay, well, delta squared is less than delta, provided delta is less than 0, right? So 1 over x squared plus y squared is greater than delta. So if we want 1 over x squared plus y squared greater than n, where n is again any positive number, let delta equal 1 over n, and if we're in that little circle of radius delta, we know that this has to be greater than n. So we can get 1 over x squared plus y squared to exceed any number we want. Okay, now, what if we wanted the limit as xy approaches 1, 1 of 1 over x squared plus y squared? Let me conclude this. Well, intuitively, one over x squared plus y squared equals 1 at the point 1, 1. it doesn't vary much if xy is close to 1, 1. Now, if xy is within a circle of radius delta, and we don't lose anything by assuming that delta is less than 1, because we're trying to restrict xy to be as close to 1 as we want it to be. So we want the point xy to be close to 1, 1. So we really think of delta as being a tiny number. Okay, then, I guess I want to fix it here. So here's the point 1, 1. Here's your circle of radius delta. And here is any xy within the circle. We can say that the square root of x minus 1 squared plus y minus 1 squared, which is the distance, of course, from xy to 1, 1. And I say it's less than 0 because I'm being careless. It's less than delta because you're within this circle of radius delta. Well, we can then say that x minus 1 squared plus y minus 1 squared is less than delta squared. And since delta is less than 1, delta squared is less than delta. If you multiply a number by a number less than 1, you get a smaller number. So if you multiply delta by itself, you're going to get a number smaller than delta, as long as delta is less than 1. And I guess we better say delta is greater than 0. Don't want delta to go into the negatives. Can't have a circle of radius, negative radius anyway, but it doesn't hurt to say it. Okay? Now, question then is how close well, trying to think what I can say in a small space here. We want to conclude, let's say we want to conclude now using a smaller board. We want to conclude that 1 over x squared plus y squared is close to 1 because we know that if we evaluate this at 1, 1, we're gonna get 1. We're not gonna get 1, we're gonna get 1/2. Okay. So we just do the algebra of this. I didn't have room to do it there. I ran out of room. But from this, we expand, and we get x squared plus y squared minus 2x and minus 2y. I'll write that as minus 2 times x plus y plus 2 is less than delta. Okay, x squared plus y squared is what we want. So x squared plus y squared is 1. And what's x plus y? Well, x plus y is close to 1, right? It was close to 2. And x squared plus y squared is not equal to 1, it's equal to 2. Okay? X squared plus y squared equals 2, and x plus y is close to 2. Now what's the maximum possible value of x plus y within this ball here? Okay, where are we going? We got minus 2 times x plus y, and then we've got plus 2, right? If x plus y was 2, then this would be negative 4 plus 2, so this would be negative 2. So x squared plus y squared would be less than delta plus 2. Is that clear? We know that x plus y is real close to 2 if delta is small. So we know that this is going to be close to a negative 4 here. So we can say that put this in parentheses, just kind of intuitive playing around with it to see what to do. X squared plus y squared is close to 2. X plus y is close to 2. If this is close to 2, then this is close to delta plus 2, right? Okay. So how close is x plus y to 2? What's the maximum difference between x plus y and 2? Well, how do you get the maximum of x plus y? the line x plus y equals constant, but any line where x plus y is constant makes a 45-degree angle with the coordinate axis and has a negative slope. So here's a line x plus y equals constant. It's actually the line x plus y equals two plus delta, because x plus y is 2 here, and you go another delta perpendicular to this line and you're out here. So the maximum turns out occurs here. You could write a function that gives you the distance to x plus y as a function of where you are on the circle. And you could maximize that. So you parameterize the circle, write distance from the origin out to point on the circle, and maximize the function, just a function of one variable, just a first derivative test, and you would conclude that that's it. So, just showing you that you get into a lot of detail on all kinds of pre-calculus and calculus notions. In any case, by this argument, I'm not going to go into gory detail on this argument, but there are a number of ways of proving it, and the easiest is the geometric argument that I'm making here. So, x plus y is less than 2 plus delta if x, y is inside the circle. So now, we can say that since x plus y is less than 2 plus delta, that x squared plus y squared has to be less than this expression. Just replacing x plus y by 2 plus delta. X plus y can't be bigger than that, so it has to be less, and x squared plus y squared therefore has to be less than this. And then just a little arithmetic. This is 2 plus delta plus 2 delta. So that x squared plus y squared is less than 3 delta plus 2. So now, going to epsilons and deltas that you remember so well and love. Okay? If we want x squared plus y squared minus 2 to be less than epsilon, just confine x, y to a circle. Of radius greatest delta about 1, 1. For delta, is less than 1/3 epsilon. If delta is less than 1/3 epsilon, then 3 delta is less than epsilon. So that x squared plus y squared is within epsilon of 2. And epsilon can be small as we want. Now this is what this inequality expresses. X squared plus y squared is within epsilon of 2. That's all this says. If you want x squared plus y squared to be, I'm going to say epsilon close to 2, just confine x, y to circle the radius delta about 1, 1. Where delta is some number less than 1/3 epsilon. Okay, that's a fairly rigorous proof. I didn't exactly wave my hand over the idea that x plus y has got to be less than 2 plus delta. It seemed pretty obvious that that's a good suspect, okay? Make sense? Okay. So except for that step, which I didn't fill in, and you can think it through and see if maybe I was wrong. If I'm wrong, well, certainly x plus y is going to be less than 2 plus 2 delta, all the way out here. Okay? And you could have used 2 plus 2 delta. You'd have gotten a 4 delta here, and you'd have to let epsilon, you could let delta be less than 1/4 epsilon. Doesn't matter if you do overkill. You know, letting x plus y